Friends, let's continue with our series Algebraic Identities, and in this third part we will be dealing with the identities a plus b whole square equals to a square plus 2ab plus b square and a minus b whole square equals to a square minus 2ab plus b square. The learning objectives for the day are: first, we will validate the identities with pictorial demonstration. Next, we will expand and factorize algebraic equations using the identities. And finally, we will find the square of the numbers using the identities. The first identity is a plus b whole square equals to a square plus 2ab plus b square. Now, in order to validate, let's use some integers. So we are taking 3 plus 2 whole square. The value of a as 3 and value of b as 2. For that matter, you could have taken any other integers as well. So a square means 3 square plus 2ab, that is 2 into 3 into 2, plus b square, that is plus 2 square. So we'll have 3 plus 2 as 5 square equals to 3 3s are 9 plus 2 3s are 6, 6 2s are 12 plus 12 plus 2 2s are 4. So if we'll add everything, 4 plus 12 16, 16 plus 9 25. So 5 square is 25 equals to 25. Now let's validate the identity with the help of pictorial demonstration. First we had a square as 3 square, 3 square equals to 9. So a square of 3 by 3 having 9 blocks plus 2ab, 2 into 3 into 2, 2 3s are 6, 6 2s are 12. So we'll get a rectangle having 12 blocks plus b square was 2 square, so 2 square equals to 4. A square having 4 blocks equals to, now combining these three, we should get a square of 5 by 5, that is having 25 blocks. So let's see whether we get that or not. First, a square, that is 3 square equals to 9, combine plus b square, that is 2 square equals to 4. Now we had plus 2ab as 12. So first let's use 10 blocks to combine it like this. Now the cavity that we have will be filled by the 2 remaining blocks. So if you can see, we have got a square of 5 by 5. That is 5 square equals to 25. So the identity has been validated with the help of pictorial demonstration as well. The next identity is a minus b whole square equals to a square minus 2ab plus b square. So for this as well, let's use some integers. So in this case, we are using 5 and 2. Again, you could have used some other integers as well. So we are using a as 5 and b as 2. 5 minus 2 whole square. First, a square, that is, we will get 5 square minus 2ab. So we will have minus 2 into 5 into 2 plus b square. So plus 2 square. 5 minus 2 will give us 3. So 3 square equals to 5 5s are 25 minus 2 5s are 10. 10 2s are 20. So minus 20 plus 2 2s are 4. So 3 square is 9. And adding the like signs first, 25 plus 4 will give us 29 minus 20. So 9 equals to 29 minus 20 equals to 9. So now let's validate the identity with the help of pictorial demonstration. So we had a square as 5 square equals to 25. So 5 by 5 square having 25 blocks plus b square as 2 square equals to 4. So as 2 by 2 square having 4 blocks minus 2ab, 2 into 5 into 2. 2 5s are 10, 10 2s are 20. So this block of rectangle having 20 blocks should be removed or subtracted. And after doing all the operation, we should be left with a 3 by 3 square having 9 blocks. So we had a square having 25 blocks plus a square having 4 blocks Now the rectangle with 20 blocks should be removed. So after removing the rectangle with 20 blocks, we are left with a square having 4 blocks plus a rectangle having 1, 2, 3, 4, 5 blocks. So if we'll add, we'll get 4 plus 5 equals to 9, which can be transformed into a square having 9 blocks, or a 3 by 3 square equals to 3 square. So even this identity has been validated with pictorial demonstration. Now let's solve some questions. The first question is expand 4x plus 7y whole square. Now as you can see, this is in the form of a plus b whole square, where 4x is a and 7y is b. Since the identity is a plus b whole square equals to a square plus 2ab plus b square, we can expand it as 4x whole square, that is a square, plus 2ab as 2 into 4x into 7y plus b square as 7y whole square. So 4 4s are 16, x into x square, that is 16x square, plus 2 4s are 8, 8 7s are 56, x into y xy, 56xy, plus 7 7s are 49, y into y square, 49y square. So the final result is 16x square plus 56xy plus 49y square. Similarly, next question. This is in the form of a minus b whole square, where 5p is a and in place of b we have 6q. So a minus b whole square. Since a minus b whole square equals to a square minus 2ab plus b square, so in place of a square, 5p whole square minus 2ab, 2 into 5p into 6q plus b square, that is plus 6q whole square. 5 5s are 25, p into p square, so 25p square minus 2 5s are 10, 10 6 are 60, p into q, pq, minus 60 pq, plus 6 6 are 36, q's are q square, 36q square. So the final result is 25p square minus 60pq plus 36q square. Now the next type of question is, we need to find the square using suitable algebraic identity. The first question is 93 square. Now we need to find the square but using algebraic identity. So let's expand 93 as 90 plus 3. So we can express 93 square as 90 plus 3 whole square. This is in the form of a plus b whole square, where in place of a we have 90 and in place of b we have 3. And since a plus b whole square equals to a square plus 2ab plus b square, so in place of a square, 90 square plus 2ab as 2 into 90 into 3 plus b square as 3 square. 9 9s are 81, and since we have 1 0, after squaring we'll get 2 zeros. 8100 plus 2 3s are 6, 6 0s are 0, 6 9s are 54, that is plus 540 plus 3 3s are 9. So if we'll add everything, the result will be 8649. So we found out the square of the number using algebraic identity. Now next question, 79 whole square. Now this can also be expressed as 70 plus 9 whole square in the form of a plus b whole square. But since rounding of 70 will give us 80, that is 79 is much closer to 80. So let's write 79 square as 80 minus 1 whole square, just for a change. So in place of a we have 80 and in place of b we have 1. And this is in the form of a minus b whole square. Since a minus b whole square equals to a square minus 2ab plus b square, so we can write it as 80 square minus 2 into 80 into 1 plus 1 square. 8 8 is 64. Since we have 1 0, after squaring we'll get 2 zeros. 6400 minus 2 zeros are 0, 2 8s are 16, 160. So 160 into 1 will be 160, that is minus 160 plus 1 1s are 1. Now let's bring the quantities with positive signs together. 6400 plus 1 minus 160. 6401 minus 160, and upon subtracting the final result will be 6241. So this is our answer. Now next type of question, factorize using algebraic identity. First question is 9x square plus 42xy plus 49y square. So whenever we have such questions wherein we need to factorize using algebraic identity, the first thing that we need to do is focus on the quantities which have square. Over here, 9x square and 49y square. Now, 9x square can be expressed as 3x whole square, as 3 3s are 9, x into x square, 9x square, and 49y square can be expressed as 7y whole square. 7 7s are 49, y is a y square. So we have got a square as 3x whole square and b square as 7y whole square. Now let's express the middle terms. Plus 2 into 3x into 7y. 2 3s are 6, 6 7s are 42, x into y, xy, 42xy. So we have got this in the form of a square plus 2ab plus b square. Since a square plus 2ab plus b square equals to a plus b whole square, we can factorize this as a plus b whole square, that is 3x plus 7y whole square. Next question, 25m square minus 40mn plus 16n square. Now the terms with square are 25m square and 16n square. 25m square can be expressed as 5m whole square, 5 5s are 25, m is m square, 25m square. And 16n square can be expressed as 4n whole square. 4 4s are 16 and n's are n square, 16n square. Now the middle term, since we have a minus sign, so minus 2ab minus 2 into 5m into 4n. 2 5s are 10, 10 4s are 40, m into n, mn, 40 mn minus 40 mn. So this is in the form of a square minus 2ab plus b square, which is equals to a minus b whole square. So we can express this term as 5m minus 4n whole square. So this has also been factorized. So now try these questions. These are similar to the ones which we have discussed in the video. If there are any problems, let's discuss. Thank you and have a nice day.